Okay, the probability of an event is found by taking the number of items that you're interested in and dividing it by the total. And if you want to convert it to a percent, you multiply by 100. So that might sound familiar if you checked out the information on percentages. So in this first question, they need a 5 or 6 to win. So what's the probability that they win? There's two ways that they can win. That's the amount we're interested in, is how we're going to win. There's two ways we can win. And then you divide by a total. It's a six-sided die, so there's six different ways that we could roll that die. So I've since fixed this document, but if you divide 2 divide by if you do 2 divide by 6 in your calculator, it's not 0.167. I don't know what I was thinking when I wrote that. 2 divided by 6, to convert that to a decimal, it should be 0.33333. Okay. So question 2, a player has to roll a 1 on a board game in order for the character to make it to the winning location. So previously they rolled a 2, a 3, a 2. Oh man, it's agonizing. 5, a 4, a 5, a 3. They just can't get that 1. So what's the probability that the next roll is a 1? You know, when you calculate a probability, it's the number that you're interested in. There's one option, so 1. And then we divide by the total number of possibilities. When you roll that die has no memory of these previous rolls, right? So there's still only 6 options when you toss that die. So it's a 1/6 chance. Okay. So it doesn't matter about all this other stuff, about all these previous things. I think that's a lesson really for younger kids too, is that they think, man, I'm bound to win by now. It's the same thing with a scratch ticket too. If you keep buying scratch tickets, you keep losing. You're like, okay, well, today's my day. I've lost so many other times. The scratch ticket company has no memory that you lost all those other ones. That ticket that you just purchased has no memory of all the other ones. If you want to get really technical, the probability might be just a tiny, almost infinitesimally small increment higher probability that you get the next one because you took some losers out of there, some losing tickets when you bought all those other ones, but still, it has no memory of your previous losses, right? Okay, so this next part is calculating something called expected value. And this is what you'd want to do if there's several options and if you want to know whether you have a better chance of winning or a better chance of losing. So there's a $2 scratch ticket. It's a dollar sign. Okay. $2 scratch ticket. There's a 0.1 chance you make your money back. So you break even and get 0. 0.2 probability, so about 20% chance that you get an extra $2. So it's a $4. So you win $4, get $2 back plus an extra $2. There's a 0.05 chance that you make it big. And then the only other option is losing the $2 that you started with. So to calculate this thing called an expected value, you take the probability of each possibility, so 0.1, and you multiply it by the dollar value. This 0.1 is a probability of making your money back, so that's getting $0 out of the game. This 0.2, we're going to multiply that by positive $2. Sorry, I meant to be 0. And then the 0.05, that's a probability for gaining your money back plus an extra 50. Okay, and so you see that I've got plus signs to the right. We're adding all these. So once you multiply, then you add all these up. That's called your expected value. But there's one other event we haven't considered. With expected value, your probability should add up to be 1. Okay. There's one other option. These are all of our winning ones. That's what we're really concerned with, but we always have to remember the chance of losing. So this next one, let's see. If it's the only other option, then take 100% as a decimal. Subtract your 0.1. Subtract your 0.2, subtract your 0.05, subtract all the other options, and this is the probability of just straight up losing that money. And this is now going to be a negative $2. All the other ones are positive because we were gaining money. Negative means we're losing money. And this computation over here is the expected value. Okay, so 0.1 times 0 is 0. 0.2 times $2 is 40 cents, 0.4. 0.05 times 50, if you're ever not sure. Got Mr. Calculator. Oops, that should have been 50. So $2.50. And then we got negative 2 times 0.65. That was negative 1.3. Oh, wait, negative 1.3. Yeah, that was it. Okay. And then add all those up. So you got 0.4 plus 0.25, then minus the 1.3. So, oh, I mistyped something. Sorry. 0.4 plus 2.5 minus the 1.3. So that's a positive $1.60. So the same thing I got here. Yep. Okay. So with expected value, if it's positive, that means you're making money on average. Okay. If you keep playing this game, you're making money. If it's negative, that means you're going to lose money if you keep playing the game on average. Now, there's obviously sometimes if you were to just go up and pay the money, you win your $50, and that's not $1.60, right? What expected value is telling you is if you were to keep doing this infinitely for all of time, you expect to win $1.60 on average per game. Add up all your winnings, divide the number of games you played, it should be $1.60. Okay. So it's positive. So this is good. Expected values are never positive in the real world. Okay. If you're at a casino, if you're playing a scratch ticket game, they purposely make them negative. There are, I guess, rare exceptions. There is some students, or maybe a student at MIT a long time ago, that found out the way they were playing a certain lottery game. If they just bought up all the tickets on a certain day, they had a positive expected value. There's still a chance they could lose money, but what they did was they got investors. The investors gave them a bunch of money. They bought up all the tickets, and it worked out. They ended up making a huge profit in just one day. So if a game has a positive expected value, you've found a secret. You should play that a bunch. They almost always are negative. Okay, then part 4 says in the game in part 3, how much did you expect to win or lose if you bought 100 tickets? Well, we got a positive $1.60. We're winning $1.60 on average. So if we're going to do that 100 times, we just want to multiply those two. So we'd expect to win $160. It's a really low chance we get exactly $160. If you were to do this, it might be 150 or it might be 170, but our target, what we should expect is $160 based on these numbers.